This is part 2 of the exponent laws, and we're going to continue talking about the other 3 exponent laws. And so our new learning target is I can use the 6 exponent laws to solve problems. All right, so in total, we're going to have 6 exponent laws we're going to explore this year. The last video, we looked at the first 3, and now we're going to look at the last 3. And so I can use the 6 exponent laws to solve problems. The first one we're going to look at today is actually the 4th one we've looked at so far, and that's the power of a product. And so just to recall what we did last lesson, we looked at the product of powers, then we looked at the quotient of powers, and the power of a power law. Now we're looking at the power of a product. So that's the 4th one we're going to examine. The 5th one is the power of a quotient. And the last exponent law we're going to be looking at this year is the 0 exponent law. All right, so just like we did last video, I'm going to go through several different examples of each of these laws and how you're going to encounter them this year. So the first one up is the power of a product law. So power of a product law. So not to be confused with product of powers when product of powers or power of a power. This time we have something different. We have the power of a product. And so when we're working with the power of a product, an equation that could define the power of a product and what it would look like is when we have our bases, a times b to the power of m can be written as a to the power of m times b to the power of m. Now, last video I went through and I showed you with repeated multiplication what this would look like. But now that you have an idea of how the exponent laws work, instead of showing you the repeated multiplication for these, I'm going to jump right into how we would apply these laws. And so as an example of what you might see, how you might encounter this, I have to change pens here, but if you had, I'm going to have to change pens. If we had 2x squared, remember what this means is I have 2 groups of 2x, but according to my power of a product law, my bases are being multiplied and being raised to the m power. And so what that equals is my m being distributed into both of my individual bases. Now, why do we do that? Well, if we look at a and b here, or my 2 and my x, and keep in mind that I'm multiplying these 2 by one another, these already have an exponent. So if I just have a value of 2, this is actually 2 to the power of 1. And x is x to the power of 1. The reason this is helpful is this could help me remember that when I'm multiplying, just like I would do in my power of power law, when I'm multiplying my exponents, that gives me something to multiply this 2 by. And so one way we could think of this is 2 to the power of 1 times x to the power of 1 to the power of 2. Now when I distribute my exponent 2 into my brackets, I would distribute it to both sets of 1s. So this becomes 2 to the power of 1 times 2 times x to the power of 1 times 2. If I bring this up here, this is equal to 2 squared times x squared. Now 2 squared is the same thing as 4 times x squared, which we can't simplify any further. So this would be my final answer. Now, as you get more comfortable working with these laws, you don't have to show this much work because you're just going to be able to distribute this 2 with this exponent and this exponent back into the x as well, which will be a shortcut to giving you 4x squared. But notice the differences in the power of product law with the power of a power law. So with the power of a product, remember I have two different bases. So I have a and b, or 2 and x, as our example showed, and I'm distributing my exponent into both the bases. With the power of a power law, we were only working with one base, and we were working with in those specific examples with more than one exponent as well. So next we're looking at power of a quotient law. So a power of a quotient law is very similar to my quotient of powers, and also very similar to the law we just looked at, the power of a product. So with the power of a product, remember that we were multiplying our bases, and we had to distribute our exponent into the base. And with the power of a quotient, it's very similar, but instead of multiplying my bases, a and b, I'm dividing my bases, a and b. So a divided by b to the power of n is equal to a to the power of n divided by b to the power of n. And so what this might look like as an example is if I have a value, and let's say we have a numerical value of 5, and I have another numerical value of 4 squared. In order to solve this, remember that just like in the last example where I had 2 times x squared, both of those were raised to the power of 1. It's the same with these values here. They have an exponent of 1, meaning I have something to distribute this 2 into. If I were to show this one with repeated multiplication, it could look something like this: 5 times 5 over 4 times 4. Or, if you want to use those brackets, 5 over 4 times 5 over 4. Which, if I simply distribute my exponent into my 5 as well as into my 4, this is going to leave me with 5 squared over 4 squared. And with these numerical values, I can expand them to give me 25 over 16. Now, when you're left with a fraction written as a rational number, if it's able to be reduced, we would reduce it. But in this case, this is my simplest form I can get while keeping it a rational number. You could make it a proper fraction, but something like this is completely fine. And our last law we're going to look at is the zero exponent law. Now, the zero exponent law is a fun law to look at just because it's quite quick. Now, with the exponent law, remember that a to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So for example, 2x to the power of 0 is equal to 1. 4x over 5z to the power of 0 is equal to 1. Now I know it's kind of difficult to think of an exponent of 0. Now let's go back to our quotient law that we looked at last class. So the quotient of powers. So if I have 2 to the power of 2 divided by 2 to the power of 2, we know that this is equal to 1. We could expand this, and so if I look at 2 squared divided by 2 squared, we could say that this is equal to, well, 2 squared is equal to 4, and 2 squared is also equal to 4. We have a number divided by itself. 4 divided by 4 is equal to 1. Now, if we apply the quotient law here with my exponents, so 2 squared divided by 2 squared, we could rewrite as 2 to the power of 2 minus 2, which is equal to 2 to the power of 0. And according to our law, our zero exponent law, that's equal to 1, which, if we make sense as to what this statement is saying, 2 squared divided by 2 squared is equal to 4 divided by 4 is equal to 1, because we're dividing a number by itself, we can show the same concept, but with exponents, which means that this value here is equal to 2 to the power of 0, which equals 1. And so remember, with your exponent law, anything to the power of 0 is equal to 1. So if you have a really terrifying looking exponent, so maybe 14x cubed y squared z divided by 2x 13 as an example, but we raise this to the power of 0, this is equal to 1. Now if we look back at our learning target, we've used 6 exponent laws to solve problems. The 3 we looked at today was the power of a product, the power of a quotient, and the 0 exponent law. I would encourage you to go through the video again. Any thing I went too fast through, I would encourage you to pause, write the notes, study the question, and think about conceptually what we're doing here. And the next series of videos are just going to show several examples where we go through each of the different exponent laws that we're going to be looking at this year.